Hi, welcome to the pre-calculus lecture series. And today we're going to talk about section 2.5. We're going to talk about the linear functions. This is our first very basic function we're going to discuss in the pre-cal. So we're going to take a look at linear functions and what type of the model and how can we apply it in the real life situation here. Okay. So let me go to our worksheets so that you can see what type of the problems we have. Okay, so the first things here we're going to talk about is what is the definition of the linear functions here, right? So here, let's take a look at linear function. Okay, so the linear functions. So basically we say a linear function is a function of the form y is equal to the mx plus b. Okay, so let's just turn we're very familiar with. And then the graph of the functions is kind of obvious, right? So the linear functions here, right? So the linear function and the graph of the linear function is a lines here, all right? So the linear function, that means every function you can write with y and x. So that means just y and x, right? You cannot have a y square. You cannot have like x cannot be like in the denominator, cannot have a power. It's just a simple y and x here. All right, that's why we say this is a linear functions here. So every linear function you can always change to the y equal to the mx plus b. So let's try to refresh memory. What is the m's here? This is what we call is the slope of these lines, right? And what is the b's here? Very careful. B is what we call is the y-intercept here, right? That's the place it intersect the y-axis here, all right? So that means any function as for both y and x, if there's no fraction, like no roots and no power, and then you know it's a linear functions here, right? Okay, so now, because every linear function, you can always change to the slope and the intercept form. Okay, so now let's take a look at our first ones here. So the first one is y, y equal to the 2 plus 3x. This is a linear function? Yes, because the x and the y, f of x is y, right? They just y and x. They don't have a square, they don't have like roots, so we know the f of x, if you want, you can write it as y equal to the 2 plus 3x. So we say, yes, this is a linear, right? Then I can rewrite it as the mx plus b. So I just switch these two. So this will be the 3x plus 2. So for these functions here, I know the slope is what? Slope is 3, right? And what is here? This is the y-intercept, right? Y-intercept is 2. Okay, so it's pretty easy. Okay, now let's take a look at part B here. The part B, the gx, we can say is y is equal to the 3, the 1 minus 2x. So you look here, then you say, hey, here, right? So y and x, it's just y and x. There's no function. So there's no like square roots and power. So we know yes. So we say this is yes. This is a linear. So how do we change that to the slope and the intercept form? Then we say, hey, here you distributed, right? So this will be 3 minus 6x. Right, so if you want, you can switch back, so switch the order. So this is negative 6x plus 3. So what is the negative 6 here? This is the what? This is the slope, right? And what is here? This is the y-intercept. Okay, now let's take a look at part C here. The part C here, this is h of x is x and 4 plus 3x here. So for this one, you see both x here. So if you do a distributive property, so this will be 4x plus what? 3x squared. Then you say, oh, something wrong here because here is x squared. It's not just x and y. So it has x squared. So this is what we say, this is not a linear function, right? So this is not a linear function. Okay, so now the d here, we say kx is equal to 1 minus 5x over 4. So for here, if you take a look, you say, hey, you mentioned this is, and the fraction cannot have a fraction. What I mean cannot be fraction, that means, the x cannot be in the fraction. So for here, the x is still by itself. And like over 4, those fraction is what? This is just a fraction for the constants. It doesn't matter. So we say, yeah, this is yes, this is a linear, right? So now here, this is y is equal to, if you break this one, it's formed separated into a 2 function here. Then switch that. So what is here again? So we say, oh, okay, so the slope is here, right? So this is the slope, and this is the y-intercept, right? So this is a y-intercept, right? So this is a y-intercept. Okay, so now, for examples here, if I do have a function, if like, so for examples here, I have a problem E here, right? So if I have function y is equal to the 4, the x plus 1. So if I put these ones here, you see, oh, so the x here is on the denominator. So we say if it is linear, they cannot be on the denominator, they cannot be in the roots. So in here, because of a value, x is on the denominator, so this is not, right? So this is not a linear function. So be careful. Like we said, the x cannot be in the roots, but the constants will be fine here. All right. So also this one's here, the next one's here, we talk about the rate of the change, right? So we said the slope and the rate of the change is here. Okay. Do you guys remember, like from the 2.4, we say the average rate of change for the linear function is a what? Is a what? Is a constant, right? So it's the slope of like the tangent lines, right? So that's why, but then for the linear, the tangent line just itself. So that's why we know the slope here is equal to the rate of the changes here. Okay, so I know like in the high school, like a lot, most of the high school teacher, they will tell you slope is rise over run here, right? All right, so that's fine. That's or if you have 2 points, the slope here will be like y2 minus y1. This is x2 minus x1, right? So it's rise over runs here. But in here, we need to be very careful here, right? So I want to interpret the slope here. Okay, so I don't, formula, I think that most of you should remember that because you learned that in high school. So the slope, what is the meaning, right? So the slope ends, right? So we said whenever x changes 1 unit, okay, and how much the y change. This is what we defined the slopes here. And then we'll be very careful here. So when we talk about the x change 1 unit, so it depends on what you measuring. So if you're measuring every minute, so how much water get in, then the slope will be whenever, when every 1 minute you increase, then y is increase or decrease. right? So that's what the slope is, negative or positive. That's increase or decrease, right? So that means that for every unit. So if your problem is X is every hour, right? So how much water get in? Then the slope means that every hour when X change, increase 1 hour, how much Y changes here, right? So like when we do the, the application problem, that's what we all need to remember is the whenever X change 1 unit, how much is the Y change here, okay? Okay, now let's take a look at this problem here, example number 2. So we said a dam is built, okay, to create a reservoir. The water levels Ft in the reservoir in time t is given by 4.5 t, and the t is here. Be careful, t is the number of the years. All right. So since the dam was constructed and the F measured in the feet. Okay. So now in here, right? Remember, right? So the slope here, right? So that means 4.5 here. Okay. So 4.5. What's that mean? Because your t is year, right? So that means every year, all right? And then the height of the water of the t is going to increase 4.5 feet. Okay, so that's what is every 1 year, right? That's we talk about is that's what we talk about is the every unit of the X, right? So right now the unit is what? The unit is year, right? So now the first thing is they say sketch the value of F here, okay? So let's sketch it. So here, so this is 0, 1, 2, 3, 4. This is a T, and this is how deep is the water. So let's say this is 10, 20, 30, 40s, right? So when the T equal to 0, so let's see when T equal to 0, so what is F of 0? F of 0 is 28. Right, so that's my first point, 28 is here, correct? All right, so then we choose another one here, said, okay, now let's see here, let's say I will choose T equal to 2. So the F of 2 will be 4.5 times 2 is 9, 9 plus 28 is 37 here. Right? So now I have my 28 disappointed. Right? Okay, so then 2 years, I go to get a 37 here. Okay, so then you connect these two. This will be your graph. So this is the F of t. Okay, and then the next thing here, they say, hey, what is the slope of it? Well, we know this is mx plus b. So what is the slope here? Is 4.5. Okay, so then the C, they say at what rate is the water level in the reservoir changes here. So remember, right, what rate? So what rate we said the level changes? So we said every what? Every, because X is year, right? So every year, the water level, because the slope is positive, so we say it's increased. The water level will what? Increase 4.5 feet. All right, so be very careful here, right? So water level is increase, right? Okay, so the reason why it's increased is because the slope is positive, right? So remember the slope is how much Y change whenever every X change 1 unit here. Okay, so now let's take a look here. The next one's here, right? So the next one's here, they say water is pumping into the water, into a swimming pool at a rate of 5 gallons per minute. Okay, initial pool have 200 gallons of the water. So they want to find the linear function of the volume and in any time t's here. So, okay, so for here, the part A, we said, okay, volume T, right? So this will be equal to our y's, right? It's mt plus b. So what is the slope? The slope is how much y change for every unit. So what is the unit here? The unit is minutes. So I say it's 5t. And what is the 200 here? Is the 200, this is the initial, right? So when t is equal to 0, that's why you get the initials here. That's why when we talk about the linear equations, right, y equal to mx plus b, of course we say the b is the y-intercept, but that also means at the initial value, right? Because that is when your x equal to 0, okay? Now let's take a look at the B's here. So let's say if the pool has a capacity of 600 gallons, how long takes it to fill? So you say, okay, I'm going to fill the 600 gallons here. It's 5t plus 200. Then I need to figure what is the times, right? So you minus 200 minus 200. So this is 400 is equal to 5t. So what t is equal to 80, right? So I know it will take 80 minutes to fill this pool here, right? Because the pool initial has 200. So remember, right? So y equal to the mx plus b's, right? In the other way to think about it, you can see here, this is, we know this is a slope, right? Also, you can say this is the rate of change, right? And then what is the b here? And the b here is the intercept, right? You can say it's the initial value. Whatever your model is when the x is equal to 0, right? That's what is the initial value. Sometimes in the business world, we can say it's a fixed cost, right? So if you have a food truck, you are making like let's say you have a taco food truck, right? So that means the B will be your fixed cost, like how much you pay for renting the truck. So even you don't do any business, you still need to pay, right? And then like the mx, the m can be the how much profit you make for every, how much, the material cost, right, for every tacos, right? So that's why y is the total cost. So you can, you can do that as the model as well. So remember the y-intercept is the initial value, and the slope is what? Is the rate of the changes, right? Okay, so here, let's take a look here. So let's say that in here, in this figure, we have a staircase, right? The origin, where the origin at the bottom left corners here. All right, so the red line is the edge of the trim board. So find the linear functions that model the height. Okay, so let's take a look here. So the first we say here, right? Let's observe the graph here. So this is the x is in inch, y is in inches here. I want to find the functions, right? The both, right? So, okay, so first things, what I need to do, I need to find the slope, right? So how do I find the slope? It's the rise over run. So they give us 2 points here. So this is 12, 16. This is 36, 32. So what is my slope? Rise over runs, right? So how much I rise? From 16 to 32. So it's 32 minus 16. How much I run here from 12 to 36, right? So it's 36 minus 12. So this is 16 and this is the 24th, right? So you can simplify that. This is 2/3. Okay, so this is 2/3. So we know the y equal to the mx plus b here, right? So I already got m. So what is my b? My b is what? My initial value. So where is this step start? Here, right? So the initial value is what? Is 8. So I know here. So this part A is here. So I know the height, right? The height of the x is equal to 2/3 of the x plus a. All right. Okay, so now the b here, let's say, if the space variable, to build a staircase is 11 feet wide. Okay, so be very careful here. Let's say it's 11 feet wide. How high does the staircase goes here? So this is the what our formula, right? So the hx, this is what? This is the height of the staircase, correct? So now the x is 11 feet, right? So now here, take a look, be very careful, right? So when I do this, I did this model by what? I did this model is by the inches here. So I need to change to the inches here. So I say 11 feet is equal to 11 times 12, right? So it's 132 inches. Now I change it to the inches, so I can say how height is 132. How height is 132, right? So how height is 132. So it will just be 2/3 times 132 plus 8. So what is the answer here? It's 96. So I know the heights here will be the 96. Okay, so be very careful. This problem is a little bit tricky. It's because you know that you change from the, so when you read the problem, you need to be very careful, right? Inch, feet, those things. Okay, so the number 5 is a very good problem also. Say John and Mary driving the westward on I-76 at a constant speed. And the figure show the distance when they travel from the Philadelphia at the time t. And we say when the time t equal to 0 is corresponding to room, okay? All right, so, and what the speed of, what the speed of John and Mary travels here, right? Okay, so the, who is travel faster and how fast, in the graph here. So without calculating, we know Mary is travel faster without even calculating, right? So why? Mary is faster. By just looking here, the reason is faster because Mary has a steeper slope, right? So the John's is kind of a little bit more flat than the Mary. So the deeper the slope, steeper the slope, it means Mary is go faster. That's the rate of the change is higher, all right? Okay, so now let's say if you don't believe, let's say, okay, let's try, let's try to figure what is the slope for the Marys, right? So, okay, so we say M, this is for the Mary. The slope for the Mary, let's try to rise over run. Let's go to pick where is my rise, where is my run. Okay, run, Mary is from here to here, it's 2 hours, right? So this is 2 hours. And how much rise the Mary did? Hey, Mary did here, right? So it's from the 0 to this point, 150, right? So, okay, so now let's take a look here. Okay, so the slope of the Mary is 150 minus 0 for 2 hours. So the 75 miles per hour, right? Okay, so now let's take a look at the slope for the John. So the slope for the John, the run still is 2, right? Let's see how much John rise here. John start here, right? So it's rise from here to here, right? So it's how much John rise here? Oh, disappeared this color, right? So John rise from 150 to 250, right? So it's 250 minus 150. So what is there is hundreds, right? So the hundreds here, so this is, so what is here? This is the 50s here. All right, so this is the John's. Okay, so now let's, what is the speed for John and Mary's, right? The slope, that means we talk about this is speed, right? is the average radius speed, right? So the function of the model for the John, all right, so the distance, we can say the distance for John, it will be what? The slope, so it's 50x, but John started at what? Is 150, right? So it's 150. So what is the, since for Mary is here, so the distance for Mary will be what? 70 what? 75 x. And Mary started at 0, so there's no y-intercept here. Okay? Okay, so now the part C is here. They say, how far will John and Mary travel at 5? Okay, so let's see the John at 5. That means because when x equal to 0, that means room, right? So John travel is 50 times 5 hours plus 150, right? So how much John travels here? John already traveled 400 miles. Now how much the distance the Mary travel at 5? Right, so Mary travel is 75 times 5. So the Mary traveled 375 miles, right? Okay. Okay, part D. Part D is really a very good problem. It's kind of like the refresh our memory. Okay, so D is here. We know the Mary is driving faster. So sooner or later, Mary going to pass John, right? Okay, so now let's say what time period is Mary behind John? And will Mary overtake John? If so, what time is here? So let's see here, Mary is 75x, right? So this is the distance of the Marys, right? So that means when the Mary going to pass John, so we say when the 75x is going to greater than 150 plus 50 times x. So how many hours this is the Mary going to bypass John, right? So this is Mary, right? So this is Mary going to pass John. So the John will be behind here, right? So now in here, so we can say this one here is a minus 50, x. So this is 25x is greater than or equal to 150, right? So these two cancel. So you divide by 25, divided by 25. So x greater than what 6, right? So that means after 6 hours, Mary will what? Mary will overtake John. That means, you know, from noon to 6 o'clock p.m., Mary is what? Mary is behind, right? Behind John. So after 6 o'clock, Mary going to take over, going to pass John and head off John. Okay, so and that's it. That's it for this lecture is linear models, right? It's a very good, it's a very important topic. So even it is very easy, but linear function always play a very, very basic role in the algebras here. So that's what is this chapter we talk about. So let's kind of refresh our memory. What is the key things here we said? What is a linear function? That means y and x has to just be itself. X cannot have like what? X cannot have like in the square roots, or like in here, the x in the square, the power cannot be that. And then in the linear function, the slope is the rate of the change. See, the way we interpret the slope is whatever the x change 1 unit. This 1 unit depends on how do you define it. Could it be 1 minute to 1 hour, and 1 cup, and so whatever, right? So it's whatever you define the relationship between x and the y here. So that means whenever x changes 1 unit, how much was y changes, right? So if slope is positive, y going to increase. If slope is negative, y going to change to the, getting smaller, all right? Okay, that's it. And it's very simple sections, but it's very important sections here. Okay, that's it for this section. And I guess I will talk to you in our next section, and you have a good day. All right, bye.